Sorry.
I'm just starting the recording. Hello everyone, welcome back to the daily week code practice. Okay, and we'll be going through the three problems, easy, medium, hard for today. Please share my screen and get started. The first problem for today, so actually I'm not sure if people have noticed it or not, but we have changed a bit of organization for the daily basis. Instead of easy, medium, hard on daily basis, you might get some medium, some hard, and some easy combination, different variants of those combinations. So for today, we have two medium and one hard problem in our bucket. Starting with the first problem for today, which is from the medium bucket. So we have to find the maximum area of an island. And we are given a 2D array. And for the definition of an island, what they say is any ones that are connected to each other in the four directions, which is essentially horizontally left and right and vertically up and down. Okay, and for those kind of connections, you have to find what is the maximum island that can be created by those ones. Okay, and if there is no island, you just have to return 0 as the maximum area. Any ideas? Anyone has tried this problem?
Yeah, it's like how we go for finding the island. We have a question earlier that how find whether there is an island or not, and you need to go to four directions. There we search for an island, and like how many islands are there. Here we need to find the area of that island and which is the maximum. I think what I did using a depth first search over here. And like in depth first search, I am going for each island and counting how many ones in that on that island, and then comparing with the and giving them and take I have taken the max variable where I have taken the like whatever the max area of that island will be my answer.
Okay, and what will be the time complexity and space complexity?
The time complexity is like n square it would be, because I am traversing all the each cell. Yeah, I'm traversing each cell.
And the space complexity?
Space complexity is I have taken one array which is a visited node, like visited array, because I need to mark whether that cell is visited or not. So space complexity is also like m into n.
Is there a way we can reduce the space complexity?
We can like the cell which we are visiting, we can mark it like a -1 or something, and then
or we can mark it 0 itself.
Yeah, or we can mark it 0 itself. But the only thing is, the only thing is if the 0 we are traversing, and if there is a cell which has a 0, oh yeah, so we are not counting that part. So yeah, 0 would also. Yeah, we are counting one. So yeah, 0 would also make sense.
Sorry, but how making that 0 will have that answer?
Sorry, could you repeat again?
Like I understood that we need to have a another like n cross m row cross column matrix, which uh, like have the visited nodes true or
Mhm.
false. But how simply changing the values to zero within the same matrix will help to find the maximum area like this.
So that is not
I,
helping you find the maximum area, that is helping you to reduce the space complexity. Instead of having another array, which will tell you whether that node needs to be traversed or not, I am using the same matrix, and anytime I have just visited one node, let's assume I have visited this node, okay, and I know once I have
mm-hmm.
visited this node, I don't want it to visit again, even in my iteration or anyone else. Like it can come from the left of this or top of this also, right? I don't want this to be revisited again. So what I'll make it will make I'll make it inaccessible for everyone. I'll mark it zero. Now any forward iteration or DFS, whatever is going on, it will not ever come back to this. But as it is DFS, the bottommost or the leaf node, when you release the last node, it will automatically have the maximum count. Because you will already
Okay.
increment that count once when you are exit, right? We are just making it inaccessible in any future iterations of DFS.
Okay.
Is it going to be the recursive DFS or iterative DFS?
Anything. You can use any, whatever you're comfortable with.
Yeah, but I did with recursive DFS.
I think for iterative, you might have to use a stack.
Stack, yes.
So recursion already has that inbuilt, so you need not.
It's my you know, try to compare if we do the DFS is would be better or BFS, like breadth first search would be better.
In this case, they both are going to give you same complexity, but DFS will be better because anytime, any tree that you are, or any island that you are looking, you always have to iterate through all the nodes in that. It's not the minimum that you have to find. DFS is usually better when you have to find the first short point where you are, you have to stop early in a tree. But in this case, you have to anyway traverse to the entire area to find that it's count of area, right?
Mm-hmm.
It's not just few nodes that you can cover and then stop. BFS usually helps you if you want to stop at specific level.
In terms of the memory usage, like if we use the queue versus stack, if we use DFS, would that the stack might grow bigger than
Right,
if we use a queue level by level?
Correct. For a very, very large tree, BFS makes more sense, but here we are given like it's just going to be 50 cross 50. For a very huge tree, yes, DFS, if it's very height is very long, then probably it will, have a very huge stack space. But even then, the BFS will have a high usage, probably less than what stack is going to use. But yes, both of them will be, in case of a very balanced tree, we have a very balanced tree, then probably DFS will give you less space as compared to BFS. BFS at that time in max will be n minus 1 nodes. That's the last level nodes. And DFS in that case, maximum stack space would be log of n.
Would suppose we have this matrix is all of them are one, okay, all the value are one. Would that the stack space would be like, I try to figure this maximum of stack would be m time n time m.
That will be n square, yes.
Okay.
Because what will happen is it will suppose start from the right side, it will keep going right, and then when it reaches here, it will suppose start moving down. So it will move in actually spiral fashion.
I see. Okay.
And then it will just end point. Yeah, good question. I think on the space complexity for this kind of scenario, BFS and DFS. Any other approach on this one? Or any question on the space and time complexity for BFS and DFS that we just discussed? Okay, I'm assuming there's no question. We'll move on to the next one. Okay. The next question is level order traversal of a binary tree. So if you are given a binary tree, what we have to do is return the nodes at each level in an array of array format, right? So suppose you have this tree, so you have to return at the first level, there's only 3. Then at the second level, you have 9 and 2. And the third level, you have 15 and 7 in this format, array of array, right? Suppose you had another node here, like to the left of 9, that would have come in front of 15. Yeah. Anyone has already done this, tried it? It's pretty much simple, not a very complicated question. I don't know why it is a medium.
Yeah, this question is a typical BFS solution. And I use a queue to put each level node to that queue. And while the queue is not empty, I iterate each level and put the node value to an array. And at the same time, I put that node left and right node to the queue. And it will iteratively traversal the whole tree and get the each level's node in to the array. Yeah, that's my solution.
Right, and what will be the time and space complexity for this one?
The time complexity is O of n is a linear because we have to iterate each node of the tree, and the time and the space complexity will be the O of n. I need the 2D array to store each node's value, so it's
let's ignore the space that is required for the result. Anything apart from that?
Except the result, we need the queue. The queue need to put each level node to that queue. Yeah. So the maximum of the queue will be the level. If the level is h, think about the last level will be the 2 to the power of h. Yeah, that's the space complexity for the maximum queue.
Right, and what will that 2 raised to power h be?
Yeah, this is an incompleted binary tree. So the last level is just 2 nodes. We are thinking of the worst cases, like there should be 4 nodes at the last level. So the size of the queue will be 4. Yeah, if the level, the root level is 0 and the first level is 1 and the last level is 2. So the number of the last level node is 2 to the power of h. H means the level. In this example, the h is 2. So the size of the last level node is 4 here. That's the worst cases if the tree is a completed tree.
Right. Let's assume we have a variation of this, but we have to return the level order traversal, but in the reverse order. Like for each level, instead of 3, 9, 20, it should be 20 and 9. And for 15 and 7, it should be 7 and 15. what will be approach in that case?
Is your question about the space complexity?
No, it's just a logic. What
Logic.
if we have to output? So here we are asking return level order traversal nodes from left to right and level by level. So if the problem changes from instead of left to right, you have right to left, but level by level. What
Okay.
will be then that?
Okay. If we need the traversal to be the right to left, we just need to put the right node first, and then put the left node in the queue.
And one more variation, if
Yeah.
they want alternate. For all even number of levels, it should be left to right. For odd, it should be right to left.
Yeah, that in that to that question, we need two stack. One is put the left first, and stack put the right second, and another stack use the reverse order, put the right first and put the left second.
Do you need stacks or queues?
To that, to your question mentioned before, we need the even level is left to right. To the odd level, we need the right to left. I'll choose the stack or queue. It's almost the same. It's just control the traversal order differently for the even level and the odd level.
Can we do it in the same queue anyhow?
Two different queue, or there are two different stack or two different queue. One is for the even and one is for the odd level.
And what will be the difference in both of the cases? If let's suppose for the even case, or let's suppose for the odd case, how will you process the odd ones?
The odd one is just you have the 9 and 20, and then you will get to the next level. In the next level, you store the node 15 and 7 in different order, just revert different order from the even order. So in that stack, you have a different order, with the even order.
I was thinking if we can use the same stack, and we are at level 3. This is what we have to process, and we'll push 3 into this one, right? And at the next level, we have 9. Let's say we have to expand this. So now stack will be empty because we have popped that element. And for 3, what we'll do is we'll push its left and right child into stack. And 20, right? So for the next state, our stack will be equal to this one, right? And then 20, and we'll pop 20 first, and then 9 first.
I think it's a stack, so we have to pop the 20 first, because 20 is a, yeah. And when we pop the 20, we put the right first, then we put the 7, and then the 15.
Okay, got it. So we are saying, okay, we need 2 stacks, right? While we are processing the current stack, we can push all the results into another stack. So when you are pushing, processing 20, we can push 7 and 15 onto another stack. And once we are done with that, we can use 9 and push suppose 1 and 8 into something else.
Yeah.
Then just replace the stack with whatever is the result, which will essentially be 1, 8, 7. So intermediate, we need one stack to gather the results till this main stack is completely used.
If each level had the same order, the one stack is enough. But if you want to have different order to different level, like the odd level and the even level, the order is different. So my solution is used to 2 stack. Yeah.
Any other ideas, guys? At least for the last variant. Sorry.
I have a question. Hey, Gaurav here. Can we solve the original problem using DFS?
Using
DFS. Instead of BFS, can we use DFS to solve this problem?
we can keep a counter and use it as a hash map or simply an array. We can and the maximum length of the array will be support n elements. We can keep it for now. We can keep n, and when we are doing DFS, when we go to the next level, we can increment that counter and append the element onto the counter. That I suppose I have a this is unique hash map. And I have, when I'm at element 3, my level is 0. So I'll append this 0 and append 3 to that. Next time I'm at 9, that's my next level will be 9. I'll have element 9, and at that time I'll have my depth, suppose, incremented by 1. Right? Now I have another 1 is already there, and then I'll add 1 and then add 9 to that. Right? And after that there's nothing element, I'll go back, and the next element will be 20. Here also depth will be 1. Right? So after that my hash map will look something like this. And this way, till all the elements are done, I'll definitely need the left to right order. But that's our DFS.
Yep. So you have to again traverse the hash map. Okay, and it's not guaranteed that keys will be in the order.
Right. What I'm doing.
So instead of hash map, can we just like use an array of arrays?
Yeah, right. So I was just saying that instead of that, we can use arrays of array, but that size of the array in initials will be we have to keep n also. That length will be order of n.
Yeah.
We don't know whether it's a skewed tree or not.
No, like keep it empty. Okay, the initial array of arrays, initialize it to empty. Okay, once we start traversing the first level, okay, which is
you're saying about having a linked list kind of
yeah,
not the array of array but linked list.
yeah,
Right.
kind of like array list in Java, because
Right.
you can insert the elements. So once you are at a level, let's say 3 is at level 0, and you see at 0th index there is like no element in that array of arrays. Create an array at that index and then put 3.
Because those depths will always be in order. So level 4, if there's this level 4, level 3 will definitely exist before that.
So just like one more variant to solve this problem.
Any other approach, guys? This one is nice to have DFS also. Guys, if we don't have any other approach, we can move to the next one. Is that okay? The last problem for today from the hard bucket is nth magical number. So a number is considered magical if it is divisible by either A or B. Okay, and we have to return the nth magical number, and it has to be in the modulo of 10 raised to power 9 plus 7. So like in the example, if n is 1 and there are two numbers, 2 and 3, what is the first magical number which is divisible by either 2 or 3? In this case, 2. Right? And second example says you have to find the fourth number which is divisible by either 2 or 3. So the initial numbers which are divisible by 2 or 3 are like 2, 3, then we have 4 which is divisible by 2, we have 6, right? This is the fourth number. The first number divisible by either 2 or 3 is 2, then we have 3, then we have 4, and 6 is the fourth number. So that's what the answer is. Okay. Same goes for the n equal to 5. You have some numbers divisible by 2, 2, 4, 6, 8. Okay, and divisible by 4 also. You have some numbers, and you have to find the fifth number. So in this case, the fifth number is 10. Okay, and we are given the constraints that the n can be any it's a very large number, 10 raised to power 9, and the value for a and b is between 40,000 and 2. Before we actually go ahead, what if our a or b can be 1 also? What will be the nth magical number? Any idea, guys? What if a number, this a or b, the two numbers that are given to us, one of them is 1?
Then it
Then
would
the
be
answer
one.
would be n.
Yeah, n only.
Right. Let's come back to the constraints of the problem. We have 2 to 40,000. Any guesses, guys? Any ideas? Any guess? Okay, suppose we are given a number x, right? Can we find how many of the elements which are less than x, okay, less than x exist, which are divisible by a or b? So any number, I'm not talking about anything in the question, it is a number, not the nth number, it is actually a number. Suppose I am given 100 and my a is equal to 2 and b is equal to 3. Okay, so can you tell me anyway how many numbers are there less than 100 which are divisible by either a or b? Okay, let's assume there's no b. Okay, how many numbers are divisible by a which are less?
50.
Okay, now assume next one is happening. How many numbers are there divisible by 3?
33.
Right. So will there be any numbers which are divisible by both?
Yes.
How many of them will be there? And which
We
will
have
be
to
the
take LCM of 2 and 3, 6, 100 by 6 numbers.
LCM of 2 and 3, which is 6. So now can we tell how many elements will be there less than 100 which were divisible by A or B? So we know how many numbers will be divisible by A, by B, and the third thing is that LCM of A and B. Let's bring it down to a smaller value. Let's say we have 10 as the value. So if A is 2, we have 5 numbers, right? Which is 2, 4, 6, 8, and 10. Right? Let's assume 11. Easier. B equal to 3. B equal to 3, we have 3 values which are divisible, right? We have 3, we have 6, we have 9. We are saying LCM of A and B, which is 6, right?
Yeah.
We have how many values for this? 1, correct? And that is 6. Now, can you tell me how many values less than 10 are divisible by either A or B?
6.
It's 5 plus 3 minus 1, 7.
5 plus 3 minus 1, right? And why have you done this minus 1?
Because we have to remove one extra 6 which comes after LCM of A and B. Matlab, 6 is repeating twice, so we have to remove that number.
So you can find the numbers which are divisible by A very easily. You can find number of elements which are divisible by B very easily. And there will be some duplicates which you can remove by using the LCM of two numbers.
Yes.
Right? So we have the way how we can find the number of elements which are less than the current element and divisible by A or B, right?
Yes.
Now, can we use that to somehow find which is the nth number? So essentially what we're saying is this is some value which can become our n. Right? This can become our n, or we have to find some value. In this case, we are choosing 11. We have to find some value which will give us this value equal to what is asked. What will be the minimum value of the magical number given the constraints?
2. So if I am asked n equal to 3, I have to find n equal to 3. And there are two numbers given. Right? What will be the minimum value? And what will be the maximum value? Given the constraints of the problem. Hey Puneet, can you please repeat? Your voice is breaking.
Sorry, I'm asking, given the constraints of the problem, let's assume this last case and these constraints, what can be the minimum value for the nth magical number? And what can be the maximum value for nth magical number? So we are given that it's a positive number, right? So without the loss of generality, can we assume the minimum number can be 1? Because are you getting it?
Yes.
Okay, and what can be the maximum magical number? So we know A or B can be maximum this value, and N can be maximum this value, right? Let's assume, let's ignore these values for now. What can be the maximum value in this case? So if we have to find only 3 elements, what will be the maximum that the output can? It may be well within inside that, but what is the probability of maximum? Can we assume it's maximum number into the number of times? Because the maximum number will take it to the highest bound, and somewhere in between you will definitely catch up with 4. Is that
Yeah.
right? Right.
If A and B both are 6, then also that number would be 18, third number.
Okay. So now this is for this problem. And what else can be your minimum maximum based on these constraints?
10 to the power 9 into 40,000.
Right. 10 to the power 9 into 40,000. So just from the problem, for the problem's sake, and we can generalize this to a specific example. Is there a way you can handle this big number in your program? So it's essentially
We have to take modulus.
Modulus. You have to return the answer as modulus. Because let's ignore that part, because if you do a modulus in between operations, you will lose this calculation. Because the modulo number, it's not always going to be a, in fact it's never going to be, because it's a prime number, it's not going to be a factor for any of those two, it's a prime number. So how many digits will be in this number?
Ten digits.
We have 10 in this one. We have 10 in this, right? So definitely this is going to cross the integers, like, or it may not fit into integer once we multiply it with this, right? Because if we have 10 raised to the power 9 into some value which again has 4 zeros, it is definitely going to be at least 30 or 14 character number, 14 digit number, and integers cannot handle this. Integers can handle only around 10 or 11. Right?
Yeah.
So let's assume we have minimum value that can be there for any problem. We have maximum value that it can attain. Okay. And we have a way to find out this equation. Right? Find out the position of that number in the entire chain based on the equation, based on the problem statement. Now, does this ring a bell? These 3 equations, if you have these 3 data points, does this ring any bell? Can we use binary search here? So we know the minimum. We know the maximum. We know the bounds for the binary search problem. Right? We can choose a mid element, okay, and then apply this formula to find out what is the position, how many numbers are less than or equal to. Suppose this is 10. there are 10 numbers which are less in this range, right, which are magical numbers. So definitely, and we are looking for suppose 5. Just take an example. So definitely this range is not worth exploring, right? We can just use our range and try the same problem on this set till we are able to find a number where we get the exact number as 5, right? Does it make sense now or not?
Yeah.
Right? And if we are able to find a number, suppose x plus 2, that will also give you a magical number length of 5, because if there's no number in between which is a magical number, right? So in that case, what we will do is keep moving left till you find this 5. And once you have reached a element of x minus 1, which is giving you suppose 4, because you have moved past the last element, this is your answer. This is your nth magical number. I hope this is clear or not. If it's not, I can take an example.
Sounds good.
Others, guys, is this clear or not? I'm not seeing a lot of interaction today. A lot of
Yeah,
silence
it's
there.
clear.
Okay.
So the time complexity of your solution is O of log n,
So
because
the
you
log of max value.
yeah, a max value. Okay. Yeah.
In this case, we can safely assume it's going to be 10. The maximum worth value will be 10 raised to power 9. This is going to be a max. Essentially, if we consider a 64-bit value also, it's going to be 64. Constant times 64 if we consider long value. So log for a max long value is equal to 64. I hope this part is clear. I'm not confused anywhere with this one. I think we are done with 3 problems for today. The ones that were in our bucket today. Is there any other approach, problem, anything for these 3 problems? Anything apart from that, or any problem, any approach that would you like to discuss for this magical number? There may be some other approach also. This was just one of the other approach that I can think of. But that may be of high time complexity is just choose from one of the numbers like A or B. Suppose A is 2 and B is equal to 3. You can choose one of them to start with, and then based on next 2 multiplication, whichever is the smaller, just continue on that. Like 2 into 2 will be smaller, so I'll go with this one. Sorry, it's like let me. So you have these numbers, right? 4, 6, 8, 10, 12, and here you have 6, 9, 12, 15. So it'll be kind of merging 2 sorted arrays. Okay, and if you see a clash or the same value, you can just take one of them. So I take the merges like 2 and then 3 and 4. But next I see there's a same number which is already inserted here, and this is also I can skip this one, right? So I can just go to the next one. It's going to be 8. But the problem in this case is this is going to be of time complexity n, which can be 10 raised to the power 9 plus 1, 10 raised to the power that's going to be a very high complexity. I hope this approach is also clear.
Yes.
And you don't have to actually expand these numbers. You can just keep a multiplication factor AI one and then keep incrementing it one by one once you use that header.
At first, I thought of this method only.
Yeah, that's what comes into mind by default, but if you run it on lead core, you'll learn to deal. From the description point of view, I think this is the easiest approach that comes into my mind and valid solution. But given that it's a hard problem and the input bounds are too high, that it definitely will fail the time complexity cases for lead code. So we need to find a better solution. Anything else, guys, you have in mind for discussion today? Okay, I'm assuming we don't have any other questions for today. If not, I can stop the recording, and if you guys have any other questions to discuss, you can stay on the call.